Hello, everyone. We propose our ESSA Talker, which achieves realistic talking head generation for multi-turn conversation. It can perceive the social relationship between the speaker and listener, thereby expressing facial movements more accurately. Talking head generation is increasingly important in virtual reality VR, especially for social scenarios involving multi-turn conversation. Existing approaches face notable limitations. Mesh-based 3D methods can model dual-person dialogue but lack realistic textures. Large model-based 2D methods produce natural appearances but incur prohibitive computational costs. Recently, 3D Gaussian splatting-based methods achieve efficient and realistic rendering but remain speaker-only and ignore social relationships. In summary, current methods for talking head generation in multi-turn conversation face the following limitations. First, existing realistic talking head generation methods only focus on the speaker-only setting. Second, mesh-based 3D approaches can achieve dynamic multi-turn interaction between speakers and listeners, but the results are unrealistic. Third, existing talking head methods overlook the importance of social relationships in multi-turn conversation. In summary, the main contributions of this work are as follows. First, we propose our ESSA Talker, which leverages 3DGS to achieve realistic and socially aware talking head generation for speaker-listener interaction. Second, we introduce a socially aware module that incorporates the crucial interpersonal relationship between conversational partners to investigate its impact on talking head generation. Third, we construct the ESSA Talker dataset, a realistic multi-turn conversation dataset focusing on social relationships, and design a 3-stage training strategy to optimize the performance of talking head generation. Our ESSA Talker consists of 3 modules: Speaker-Listener Motion Generator, Realistic Head Avatar Renderer, and Socially Aware Module. For the Speaker-Listener Motion Generator, the inputs are Speaker A's speech and flame-based motion parameters, as well as Speaker B's speech. Through a cross-attention mechanism, a socially aware fusionet, and a motion decoder, it predicts Speaker B's facial motion, which can drive the flame model to generate 3D head avatar facial animations. The Realistic Head Avatar Renderer binds 3D Gaussians to the corresponding triangular facets of the flame model. As the deformable flame model moves, the 3D Gaussians are indirectly driven to move. For a given time step, the 3D Gaussians are rendered into an RGB image through Gaussian splatting. Multiple time steps collectively render a talking head video. During training, 3DGS performs adaptive density control, under which existing anchor Gaussians may be cloned and split. The newly cloned and split Gaussians are referred to as the neural Gaussians. Each neural Gaussian is bound to its anchor Gaussian, as illustrated in the figure, thereby forming an anchor-neural relationship. The Socially Aware module employs learnable queries to process learnable social embeddings through the Motion Social Net and Gaussian Offset Net, respectively, producing motion social features and Gaussian offset corrections. This injects social relationship information into the first 2 modules. We categorize social relationships in multi-turn conversation along 2 orthogonal dimensions: blood vs. non-blood, and equal vs. non-equal, which yield 4 possible combinations of interpersonal contexts. To model these relationships, we maintain 2 sets of embeddings, each encoding 1 dimension of the social taxonomy. These embeddings serve as the learnable queries fed into the socially aware module. We adopt a 3-stage training paradigm to progressively build up the proposed framework. In the first stage, we pre-train the Speaker-Listener Motion Generator through a cold start, where a large-scale dataset is used to learn the general interaction patterns of multi-turn conversation. In the second stage, we pre-train the Realistic Head Avatar Renderer by reconstructing the 3DGS representation of the speaker. This step allows the model to acquire the ability to render speaker-specific head and facial motion. Finally, in the third stage, we introduce the Socially Aware module and perform end-to-end joint training, which integrates social relationship embeddings into the overall system. To overcome the modality gaps in existing multi-turn talking head datasets, we construct a speech mesh video triplet dataset by aligning dual talk speech clips organized into 4 social relationship scenarios with corresponding video segments from RealTalk via audio feature matching, enabling comprehensive multimodal modeling of facial dynamics. To comprehensively evaluate the capability of our ESSA Talker, we selected two types of talking head methods, namely mesh-based and image-based approaches, as baselines. The former is evaluated on the test set of DualTalk dataset, while the latter is assessed on the test set of our ESSA Talker dataset. We employ two sets of quantitative metrics to evaluate the mesh and image, one set of qualitative talking head image visualizations, and one socially aware user study. For mesh-based methods, the results are shown in the first table. We report three metrics, FD, PF, and MSE, each further evaluated across three dimensions: expression, jaw, and head pose. All models were tested on the DualTalk dataset test set. Our ESSA Talker incorporates a socially aware module, which classifies and extracts features based on different types of social relationships. This design further improves the accuracy of facial expressions and head poses in multi-turn dialogue scenarios. 2D image-based talking head methods better capture the realism of digital humans. We conducted the evaluation on the ESSA Talker dataset test set, with results shown in the second table. However, since ERNerve, SyncTalk, and Gaussian Talker are all speaker-only methods, they cannot take speaker A's facial motion and speech as conditional inputs and can only rely on speaker B's speech, which leads to suboptimal rendering quality. By contrast, our ESSA Talker benefits from its ability to support multi-turn dialogues and incorporate social relationship features, enabling it to significantly outperform the baselines. To further evaluate the rendering quality of talking head generation, we conducted a socially aware user study comparing our ESSA Talker against three representative baselines. 24 participants each viewed 4 videos generated from the same input speech and provided continuous ratings 0 to 100 on 9 subcriteria grouped into 3 high-level dimensions. These participants are graduate students and researchers with prior experience in computer vision and human-computer interaction. 10 male, 11 female, 2 non-binary, and 1 undisclosed, all of whom provided informed consent. In summary, both quantitative scores and qualitative inspection indicate that implicitly modeling social relationships substantially improves the perceived realism, temporal fluency, and social relationship accuracy of generated talking heads. The largest and most meaningful gains are in social relationship accuracy, corroborating our claim that social conditioning is essential for believable multi-turn conversational avatars. To validate the effectiveness of the socially aware module and the 3-stage training strategy, we perform ablation experiments on the ESSA Talker dataset. Overall, the full ESSA Talker achieves the highest scores across all metrics, confirming the effectiveness of integrating the socially aware module with the 3-stage training strategy. Although our ESSA Talker outperforms baselines on average, several limitations remain. Extreme head rotations and heavy occlusions can degrade visual fidelity and social relationship accuracy, occasionally causing artifacts such as distorted mouth interiors. In very long multi-turn conversations, early social cues may attenuate, slightly affecting role consistency. Moreover, our relatively small and homogeneous participant pool, mainly graduate students and researchers, may limit the generalizability of social relationship accuracy results, as different user groups and cultural contexts may perceive social cues differently. Expanding evaluation to more diverse populations is an important direction for future work. In this work, we present our ESSA Talker, a novel framework for generating realistic and socially aware talking heads in multi-turn speaker-listener interaction. By integrating 3D Gaussian splatting with a socially aware module that models interpersonal relationships, our method effectively produces facial expressions, head movements, and interaction dynamics that are consistent with the underlying social context. The framework is further strengthened by a carefully designed 3-stage training strategy and the newly curated ESSA Talker dataset, ensuring both high fidelity and robust performance across diverse scenarios. Extensive experiments and user studies demonstrate that our method outperforms state-of-the-art baselines in realism, fluency, and social relationship accuracy. Our ESSA Talker can be used for VR meetings, virtual assistants, and social avatars, where natural turn-taking and relationship-aware behavior are important. In the future, we will move toward real-time VR by using streaming audio, causal motion prediction, and faster image rendering. By providing a new benchmark for socially conditioned talking head generation, our ESA Talker represents a significant step forward in immersive virtual reality applications. That's all. Thank you.